scarier is that the world's insulin supply won't be enough to treat the growing number of diabetic patients by 2030, which is only 9 years away. Insulin, like many other proteins and peptides, contain what is known as a disulfide bond. To make things really simple, proteins like insulin require specific solidified 3D structures to function properly. Now, the problem is that current biological and chemical methods for forming these disulfide bonds are very inefficient, time-consuming, and costly because they require many reagents, tools, and complex protocols. You see, this is a problem for the biochemistry world as a whole. It's bad for academia because it delays the progress of research. It's bad for manufacturers because of low yields and high costs. And lastly, it's bad for the industry because the limit of 3 disulfide bonds acts as a barrier to innovation. This brings me to our solution, which we'll be calling thermosis. Our patented technology is a new, novel, efficient, and economic approach for selectively forming multiple disulfide bonds. Let me break down how it works. Below a certain temperature, our protecting groups attach to the 15 residues to prevent the formation of disulfide bonds. By strategically choosing the temperature thresholds for each protecting group, disulfide bonds can be formed in specific places one at a time as the temperatures increase in intervals of 15 degrees. Now, if you compare our product to current existing technologies, you will see that our product actually provides 4 key benefits over all others. Essentially, instead of using long, complex protocols and multiple chemical environments, we use a single heat control environment. This allows us to do 4 things. 1, to have a 2 to 5 increase in product yield. 2, it lets us turn a 7-day process into just over a day. 3, instead of being able to make 3 disulfide bonds, we can now make 5, which opens up a whole new world of discovery in the protein market. And lastly, it makes a long, complicated process into something that's really simple. And as someone who's worked in the wet lab setting, I really appreciate this. So, see, it's benefits like these that will allow us to look at peptides like insulin and figure out how to make them cheaper for all those in need of it.
Thank you, Farshad. Let us now take a look at the opportunity at hand. Currently, the global peptide synthesis market is growing rapidly at 13% annually to reach $1 billion by 2026. Within the natural proteome, roughly 1/3 of all peptides contain at least one disulfide bond. So our team used this to estimate our market size. Overall, we estimate a North American market $118.5 million by 2026, and we're confident in our ability to capture a large share of this market based on many advantages. We aim to do so through direct sales and licensing. For small, medium-scale companies and researchers, we'll be directly selling our thermally protected cysteine group at a premium equivalent to 50% of the increased yield. Initial production will begin at McMaster Innovation Park, where we'll rent an office space and laboratory space, and sales will be generated through a B2B sales force and distributors such as Sigma Aldrich and Nova Biochem. For larger scale companies and third-party peptide synthesizers, we'll be licensing the formulation, processes, and offer possible customization for specific reactions. These royalty rates will depend on the volume and expected savings we can achieve for these companies. Overall, in first year, we aim to achieve complete our research and development to publish our findings and standardize operational protocols. Sample kits will also be prepared to be distributed to select academic institutions and during peptide symposiums free of charge to drive traction. We'll also be developing processes for mass production to prepare for our direct sales and licensing launch in year 3. Afterwards, we'll expand internationally by going to other countries, scaling operations, and innovating better pathways for the synthesis of insulin and other peptides that contain disulfide bonds that cannot be chemically synthesized right now due to the current technology.
Thanks, Jason. We at vGen Solutions are confident that the team we have developed will allow our company to carry out this project with great success. Here we are showing our projected financial breakdown for the first 5 years of operations. And while we don't have time to walk through the document at the moment, we hope to show that we are basing our financial projections in thorough analysis. Based on these financials, we have a projected revenue of $3 million in the 3rd year. Once the contracts and sales begin, and while in the first year, expenses total $470,000. Revenue growth was calculated separately for both direct selling and licensing. Meanwhile, the expenses grow along the way to match capacity. In year 5, these figures will grow to 5.2 million in revenue and 2.7 million in expenses. Now, based on these projected figures, we require $2 million to begin and maintain our business model. These costs will primarily be allocated towards legal and admin expenses, as well as research and development and production of the sample kits. And this to cover the initial licensing from the process for the University of Windsor, and the funds will act as a cushion for any unforeseen expenses we come across. We're projected to break even in 3.3 years, and operations are expected to result in a return on investment of 137% at the end of this 5-year period. Overall, we are confident that we will be able to capture not only the insulin market, but will provide a more efficient, simplified solution with a high yield for the peptide synthesis industry as a whole. Thank you, and we're happy to take any questions at this time.
Thank you, vGen. Judges, I've lost track who's supposed to go first.
What was that?
But I've lost track who's supposed to go first. Eric, are you
I don't know.
volunteering?
I'll go ahead. A commercialization strategy. Have you talked with any of your potential customers about sales or partnering with them?
Yes, I can take that question actually. So right when we saw this technology, the thing that gave us most confidence was actually talking to professors at the University of Western who specialize in peptide synthesis. And once we got the go ahead that said that they would love to use this and make their research more efficient, we decided to really take this further. We also talked to various people at Sigma Aldrich, Nova Biochem, and Aptech specifically to see if this was something that they would like to sell on their distribution website. So.
Okay. All right. Thanks.
I have a related question about, you talk about two arms, the direct sales and the licensing. Can you break those down for me a little bit more? Is one of them these kits, and like who are you direct selling to and who are you selling licenses to?
Yes, absolutely. The reason behind having two different business models, because these different institutions, these different companies, they have very different goals. So for example, for researchers, their goal is to make their process as efficient as possible so they don't waste a lot of time waiting for the reaction to run. For small companies and even some large scale companies, they're looking for maximizing yield, which reduces their cost. And finally, for pharmaceutical companies, they're looking for innovation. And so they want to develop new products. And so the best way we thought to meet all of those demands is that we have to use two different channels. So direct sales, that's targeted towards universities, that's targeted towards academic institutions and small companies who will buy these pre-made kits of the, that's the pre-made kits. And for licensing, those will be for the bigger companies who have their in-house capabilities that they can integrate our technology into their workflow.
Got it. Good.
Alex, did you have a question?
Oh, I'm good, thank you.
Okay, great. Thank you, Team vGen.